Let's solve this particular problem. He said a thread of mercury of length 16 cm is used to trap some air in a capillary tube of uniform cross-sectional area closed at one end. When the tube is held vertically with the closed end at the bottom, the length of the trapped air column is 30 centimeters. Calculate the length of the air column when the tube is held A. horizontally, B. vertically with the open end underneath. And one of the conditions is we should take the value of atmospheric pressure to be 76 centimeter mercury. So this is about calculating gas pressure exerted on a thread of mercury under atmospheric pressure. So one of the things we write out is this. You say the first condition, let's draw it to help us understand what is happening. This is the tube. Now, let this be the mercury thread that was trapped. I'll use this to represent mercury thread. The length of this mercury thread from the question is 16 cm. Now look at the air, which is gas, trapped here. And we are told that the length of the air trapped by the mercury column, when the tube is vertical with the closed end down, which I've drawn so far, the length of the gas column is this. Now this is atmospheric pressure pushing down. So this is what the tube setup looks like. This is gas, which is air, exerting pressure here. This is atmospheric pressure exerted here. Then there is a pressure due to this mercury column. So we say let atmospheric pressure be equal to 76 centimeter mercury. Then let cross sectional area of the tube be equal to A. What it means is this tube from beginning to end, the area is the same, but the length of mercury column and that of the air can change. Then we know that volume is area multiplied by height. Now, the volume of the air molecules here, let me call it V1, is area of the thread within this space here multiplied by the height of the air molecules, 1. And this is A times, this is 30. So V1 is equal to 30A cm cube. Now, atmospheric pressure down, pressure from the air molecules up against each other. The difference is the pressure due to this height of mercury column. So we have gas pressure, I'll use subscript gas to show is pressure due to this air here, minus atmospheric pressure should be equal to the pressure due to mercury thread, H. So we see gas pressure, we're going to call it the first pressure when the volume is this. It's atmospheric pressure plus height of mercury column. So this P1 is actually, atmospheric pressure is 76 plus height of mercury column, this. And this will give us 92 millimeter mercury. Now look at the first question we are asked. If the same tube is lying horizontally. This is the same mercury thread. I'm not drawing it according to scale, but we understand what is going on. Now, this is the same air. They want us to calculate what would be the height of these air molecules. Did they expand? Did it contract? So first of all, we need to know the total pressure involved and the volume. So second volume, when it is horizontal, V2 is A times H2. That's the height we are looking for. Now, what would be the pressure involved in this situation? There's the total pressure P2 is the gas pressure, which is the same thing as atmospheric pressure, and the value is 76 millimeter mercury. So we can use Boyle's law to check what is happening in this situation. So we say P1, V1 should be centered as P2, V2. What is our P1? 92. What's our V1? 30A equal to, what is our P2? 76. What is our V2? AH2. A, we cancel A. 92 times 30 will give us 2760 equal to 76H2. Divide both sides by 76. So we have H2, the new height when it is horizontal, 2760 divided by 76. That will give us approximately 36.32 centimeters. Now let's look at the second condition. Now we are going to put the same tube vertical, but this closed end has to be on top and the open end will be down. So that's what we need to draw next. Here equally is the mercury thread, not drawn to scale. Of course, this is the height of the gas. Let's call it H3. Atmospheric pressure here. What do we notice? In this condition, atmospheric pressure minus the pressure due to the gas molecules here should be equal to the pressure due to mercury column H. Well, this H is this 16. So this minus gas pressure is the second pressure of the gas. So we can make it the subject. This becomes H minus this. 76 minus 16. That is 60 centimeter mercury. And the volume V3 under this condition is H multiplied by H3. So using Boyle's law again, we say P1 V1 should still remain the same thing as P3 V3. Remember, our P1 is 92, our V1 is 30A. Should be the same thing as our P3. Our P3, which is 60, multiplied by our V3, which is AH3. A will cancel A. So we check 92 times 30 2760 should be the same thing as 60A. When we divide all through by 60, we'll have the third height, H3, under this condition to be 2760 divided by 60, and the answer is 46.0 cm. And these are the answers for the two conditions. Thank you. I would like to have your comments on this and interact with us. Use the like, the comment, and the share. Thank you.